let's talk in this video about another interesting problem you're very likely going to see when you do interview with one of the big tech companies, which is Trie's problems. So if you don't know me, I'm Hussein Robaya. I'm a senior engineer in one of the big tech companies. Okay, so let's get started. So have you thought for once, like when you go to Google and try to search something, like how Google auto complete your search? Like, for example, say Robert, just Google do auto complete for your search. So this is what called Trie. Like Google do a big, have like a huge hash of information. So whenever you write something, they try to tell you what's supposed to be next. So I'm not going to tell you how Google works because I have never worked for Google before. So I'm going to take a very simple example and I will show you how you use the same concept, which is Trie's a problem. So let's think about having this database. Like database have a words such as food, book, full, word, fast. I mean, think about as much as data you have in the database. But for my database, only I have these. So I would assume if someone search for input FO, I'm going to suggest to him to have a food or full. Okay, because this is only two words that start with FO. If someone food or full, so food or full, like I don't put book, is that right? Because book is not my output. So my output will be either food or full. So if someone like write input like F, I supposed to return to him like anyone start with F. So I have food, full. This one also start with F, and this one also start with F. I mean, you got my point. Like it's just a search. Think about you are searching. Like if someone input only F O D, I should only return food because the only food I have in the database. So this is like my expectation of your solutions. So how we do such type of solution? Let's go back to the first one. Like if someone input food, how we give him output as a food or full. Well, this is what's called tries. So on tries, what you're going to see, what you're going to do, you're going to build your tries tree, and then whenever input come, you just search in that tree. So I will let me just build my tree based on this database and show you how that works. So I would just create for me a pen, and my try always have a root. So for my root here will be just root will be anything. This is just considered as a root. It does nothing. It's just a root for your tries where you're going to start searching. So let's go through the words one by one. So when I start with food, so I have food. So do I have food here? No. So I will create node under this one, start with F. Then do I have a child here? O, because the second character here is O. No, I don't. So I will create a child, name it O, and then do I have a something like FO, another O? No. So I will create another child here and make it O. And do I have of OOD? No. So I will create another child, make it D. So for now I have food in this way, like FOOD. So now I have another word which is book, BOOK. So again, I will start from the root. Do I have a child for the root to start with B? No. So I will create a child with B. Okay. Do I have a child with BO? No, I don't. So I will create B, and I have another child with O. Do I have a child with BOO? No. So I will create another child and another O. Do I have a child with BOOK? No. Another child BOOK. Now this is interesting. I'm looking for 4. Do I have a child in the root have F? Yes, I have. I don't need to create a node. Do I have FO? Yeah, I do have FO. Do I have FOO? Yeah, I do have FOO. Do I have FOOL? No. So I will create a child here. Name it what? Name it full L. Okay. Again, full. Do I have F? Yes, I have F. Let me just delete this for now. So I just don't mess stuff with you. So do I have F? Yes, I do have. Do I have U? No. So I will create a child with U here? Do I have FUL? No, I will create FUL. Then do I have FULL? No, so another L will be here. Okay, so this is how you build a trie. Do I have a child W here? No, so I will create a child here with W. Do I have WO? No, I'll create W, then another child to it, O, WO, R, then another child, R, then WORD. I don't have a D, so I will just create another child with D. Then fast. So do I have a fast? Yes, I do have this one. This one is F with fast. Do I have FA? No, I don't have FA, so I will create F. Then another child A. Okay, do I have FAS? No, I create another child FAS. Then do I have T FAS? No, I create T. And here where the interesting things will start. So now when someone input like example above, input like FO, I'm going to say, okay, do I have a child? Let me just clean this one before explain that problem. So if someone just like input FO, I say, okay, do I have a FO here? So I have in this one, I have a child F and I have O. Then I say, okay, I have this path. Now going from this path, what I supposed to return to this guy? Well, I could return FOOD, food. I could return FOOL, full. Okay, that is how it works. That's how we return food and full. So same thing if someone just enter W, so I will just, okay, do I have W? Yes, I have W. Here is it. What I supposed to return? For now my data set only have W ORD, so it will be, I will return just word. Okay, that's how it looks like. Bigger your data set is, more trees you have, and more information you have. But one thing interesting you need to do, because the tries need to know like, hey, where is the word? Maybe like word end here and you have more child. So you need to tell in every node to consider as the last node for a specific thing. Like what I'm gonna say here, like I have a food here, D, is that right? I should tell him this could give you food, okay? And I tell him this one could give you full. And that will help in the search. If this one, like this can give you full, okay? And this one can give you what call it word, or I don't know what is, a book, I guess. Yeah, book. And this one, this node can give you fast or word, I guess, word. And this one give you fast, okay? Because sometimes I didn't have this one, but maybe like this node give you a word, and there is another node. Maybe this one give you just word, call it WO. So let's assume this one like my. Second node my, and there's my and many. So my and many. Both of them start in same beginning, but another one will go farther. So when you build the trees, okay, I have the trees, then whenever people search, you just go through them. But there is two ways to handle this. Either we build, if you look at this problem, is it clearly like nodes problem, like you have a node and in every node could have multiple children. So this one have 3 children, okay? Same thing, they have a node, this one could have 3 children. And you have this node, and this one could have only 1 children, and this one could have 2 children. So the idea is every node could have multiple children, and every node could be an end node or not, or could be end node forward or not. So this is one solution. We could use a nodes solution. Another solution, you can use just a hash map. So that's what I am going to implement in this video. So let's get started building our data structure. As I said, I will have a trie. Every trie will have a name. It could be a character like AF, whatever, and we'll have a list of nodes as a children. In this case, I will use a hash map because I will have a key for the name of the node and value of the node itself. And I will have another string telling me if this node is the final node or not. So what I am going to do, I will just go here. I have this my simplest example here. If you see it, I have a main. Someone give me the data set with a word dataset and input, and the expectation is there's while truth will never end. Whenever someone writes something on the screen, I take it and I send this supposed to the database and tell him like what the output. So for now, I'm doing nothing, just printing whatever you input. So let's get started. So my initial start will be building my class for the try. So I will call it try in this way, and my try will have, as I said, will have a character for the telling me the name of the node. So we could call it name because it could be like C, it could be A, B. I don't know what you kind of call it. Just you kind of call it character, car name, whatever, car ID. You just call it whatever. Okay, or I would just call it C. It's up to you. And another parameter I will have it telling me if this is complete word or not. So I will have a string word. So as I said, like I could possibly, the node could possibly will be end of the word for a specific word or not. So for example, if I just go back here, this node, the word will be nothing. This one nothing. This one the word will be whatever I have here, which is word. This one will be, the word will be book, and this one is nothing. So I can now how I go through the database. And another thing I said every node could have multiple children, but my children should be a hash map because I should know like the name of the node that I'm connecting to and the value of that node. So I have a hash map for sure, since the name of the node will be character and the value will be try as a node. Okay, and I would just say child. Okay, this is my child, and I will define my constructor. So on my constructor here, I will make it very simple. My input will be just a character as a C, and the expectation is I'm going to set multiple things. This dot C will be equal to C as an input, and this dot word as initial. I'm saying, okay, this is not a word. So what I'm going to tell him, I will say null, it's empty, there's nothing here. And the third thing is my map, I will just initialize it. So, or my child's here. So it will be a new hash map, okay? And this way. Okay, so this is my tries. As I said, 3 parameters I will have for every try. C is the name of the try, which is could be A, B, C, D, E, F, whatever. The other property is word, like if this is a complete word or not. And this is the children's, I have them. As I said, I connect to children's. I should know what the children name and what the children value, so I could get it by name. So now I want to just try to build my tree, because think about this, like we need whenever we have a database, we just build our hash map. Then whenever there's a call, we just go call. We don't build every time you call. We build once and we call multiple times. That is the main idea when we want build a tree. So let's get started. So I will just define a method, and this method will call it try, and this return try and call it build a try. Okay, and we'll receive this one to receive the database. So I will be to receive the string word db. Okay, and as I would assume, this method just get called and somewhere from here before, when you just have the database. So I would just define my this one. I will say try demo 2 because I will have a try demo 1. I start the second one somehow, so I will just say new try demo 2, and I will just say try demo 2 dot build the tree. I will send him my database. Okay, so here's the assumptions: is someone have a database, and the database will go here, and this expectation should return to me what? Should return the root. Okay, the root. Okay, so this I supposed to have a database. I'm sending it to a specific function, and the function should return to me the root of the tries. So what that mean? That mean I send this database to the function, and the function will build all these trees and will return only this node to me. Okay, because this is nothing. It's just a root. Okay, so let's go back and try to implement this method. So I will start with the root. So I will say try will be the root, and my root will be a new try. And for now I just have nothing. this is just like, I will give it empty space as a root. It's just a root. So I use it just to identify all the words I have them. So I will go over the words one by one. So I would say for integer I equals 0, or you could say for string word in the words db. So I will just go over the words one by one, and then I have the words. I will go over them character by character. So I will just say for integer I equal 0, I less than word, okay, dot length, then I just do I plus plus, okay, because I just want to go over these word characters. So I would say character C will be word for the car at I. What that I mean by this, well, I want to go over this database word by word. This is the loop. We'll go over them word by word. One time I will have food, one book, full word, fast. Then I will go over every single word characters. I will go over F, O, this. So one time the C will be F, then O, then another O, then D. If I go to the way that I build the tree, so I would, before I go through it, I said like, okay, first thing I'm going to take the root for every time I start from the root. Okay, that's what I said. So that's mean for every time I will have a try will be current equal the root. Okay, so this every time whenever you start a new word, I should go back, start from the root. So here I'm saying well, if the current dot map or to dot children dot contain keys, like I have this child contain keys, which is C. If I have this C as a child, I will not create it. I will just say current will be equal the current dot child dot get. Okay, so well, I would just go to the children or go to that node. What that mean, like if I just go back to the try, like I go here, if I have if F already created by this path, I will just pull that F as a new head. So I will just as a current node. So I start go look for inside that, or inside the children of that F. So I will just change the pointer. So in the beginning, the pointer, for example, in the root, then if the first character is F and I already have F, I will just get F as a node and I just continue. Okay, else if I don't have it, so I should create it first. So I should create try a new node, okay, or a new try, you could call it, call a new try in this way, and my character will be whatever C is, because I have a B, C, whatever. Then I make it as a new child to the current, so it will be current dot what dot map current dot map this or child dot put. I will put C, and the value will be the new try. Okay, and now here my current will be equal to the new node, because now I have a new try as my current. I just change it. And remember, we said whenever we build the word, the last thing we need to do after we add the word, we just need to mark the last node in the word as the word. So I was define the current will be equal dot word will be whatever word is. So what that mean? Okay, you are going through this tree, and you create F D D, then or F O O D, then in D you should mark it as you give it the name of the word, which is food. Okay, that's exactly what I am doing here. Then by the end, when I'm finished, I will just return whatever is the root, because my expectation is returning the root. And by now I built the tree. The question here, can we improve this code a little bit? I think yes. So I could say no. Instead, I'm doing this. I will just only create a new node when there is no node there. then I try to create a new node and add it in the map. And anytime I am moving, I will just get whatever is that node is. So if the node is there, I will just get it and consider it my next node, or that the child is there. If the child is not there, I will just create it and add it here. Okay, I mean, yeah, just make the code less. I like it. So now I have my database here. I'm good. They have the root of the try and someone now search. So my expectation is when someone click here, there's supposed to be method called search, and in the search I should send the root of the try, and I also should send whatever the search term you want, and that method should print to me like, oh, you could just print it, could return, just up to you. For me, I will just make it a print. So I will have here a method called void. It is this method, and this method will get the root of the, I guess, the try, and the search term should be the string. Okay, so now, okay, I have try both. I need just go through the try or the characters until I find them. So what I will do, I say, okay, for integer I equals 0, I less than the word, I less than word. And this search term here I have dot length, then I plus plus. I'm going through this characters. So the idea is, okay, I always try to use car C will be search word dot car at I. Okay, and here I'm just saying, okay, if the try dot or root here we are sending, well, you can call it root here. I mean, you could call it try, because it's not nice to call it root when I move through the node. So if a try dot map or children dot contain the keys, I'm good. The only reason I will not be good if the key is not there. So if the key is there, I'm good. If not there, I should return. Okay, so if it's there, I'm good, as I said. If it's not there, I should return. So only case I will return, that means this word is not there. I will not print anything if the child is not there. So think about, you have this database and someone input like word code. So if someone write code, you try to say, do you have a K here? No, I should return. I should not continue my search in any point. Like if someone like enter like FO, then the like different word, like there is no other word than here. I don't have another word than food and full. If there's another word, another third character different, I should just return. I should not continue and waste time searching because that word or that string is not there. So okay, if we are okay, we have no problem. Also I will just exactly do what I did before, like try dot map or the child dot get whatever the C is. So same what we did here. We just move to the current. You just call the current. When we done, so now when you done here, well, this one will return if you have the search. If we have the search term in the tree, so if we have, for example, if someone input foo, so I have FO, it should return this node. Okay, this node should return FO, and from this node you can print any child it have. So if someone enter like a whatever like WO, so it should return this node, and then we print all the child of this node. That's the idea of the try. So yeah, for now I know where I am. If the search term is not there, I already returned it before. I will just define a method called the print, just for a print to the tree. So I will say print try, and it will receive try, called try as a node. Okay, and the job of this method is just printing. Okay, so I will just call it from here, just print it, and I'm sure here I will call the method here on that try. So that's mean, okay, I know where we are, I know the current is, so I'm not going to print any children for that one. So what the checks I'm going to do, well, if the try in this way has a word, so it's not equal to null, so that means it does have a word. This is an end for some other word. So system out, I will print try dot word. Okay, that means I'm good. There is I mean, this is a word. I want to print it. What other options I have? Well, if the try dot map or children dot size equal 0, that means this is the last word in the tree, so I should end. Okay, I should return, not end. I should just return. Okay. Otherwise, well, if you give me any other node, I should go through all the children of that node. So if you give me F, I should go through A, D, U. Okay. If you give me L, I should just return. And we now return by L is this one. This one should catch that part. But if it has children, so you could just say for integer. I'm going through the car C in the tries dot map or children dot keyset. I mean, you really don't need this line above, because if there is no children, this one will not run. So in this case, if there is, I will just, for every one I call the children for, I will call try dot child dot get for C. Okay. And as I said, you really don't need this part, because, well, if there is no children, this loop will not run, and we will not call this one. I will already return out this. Okay, so I would just, well, you don't need this, so let me just remove it. Now I should be good. I build the try. I try to search in the try, and that is, so let's try to see if we for code work. So let's give it a try. So I will just say run. Okay, so I have, this is the output. So if I click F, my output will be food or full. If only, I should have fast, full, food, full. See, if I FU will be full. So yep, that's the first solution, which is like, okay, yeah, I just built a try. The other solution here will be you building a hash map, which is way easier than this solution. It's just like a very simple solution will be. So they get start implement the second solution. So what I mean by hash map? Well, think about, you are going to build a hash map for this database. So you will say, okay, anyone start with F, I will add it as a key, and the value will be food, full, fast. Anyone start with FO, I will add it as key as FO, and the value will be food and full. Anyone start FWO, I will add F full, and I mean, you just go through the key, and you just build your data set. This is quite simpler, but it's not recommended. But I mean, well, you're gonna do it in this video. So in this case, I'm going to again build my hash map, like building my try. So it will be hash map, and my hash map will have a key as a string, and the value will be, in this case, will be as array list. Okay, array list of string, because every key will be anything, and the value will be multiple values. So I call it build try or build map here, and this should get an input as a string for my database. Okay, will be word db. Okay, and in this case, I'm going to build my try from here. So it will be this. So as I said, I mean, again, I have try demo. So I would just create a try demo, will be equal new try demo, and because I need to build my hash map, so I will have I will call this method to return my hash map. So I will call it map db. You can't call it anything, and this map db you could get the value for it from this one dot build map. So I just building map with my database. What I mean here, I'm just, okay, I'm having database of strings. I'm going to send it to this method. It will build a hash map for me, and I will just print it. So if I just take this simple example for you, how the keys values will look like this: food, book, full, whatever. So F will have a food, full, FO will have these two, FOO will have these two, and food alone will have this. So this is the key, this is the value, this key, this value. It's just a wait. So when someone search for FO, the access will be of 1 because I'll just get this one. Oh, you request FO. This is the data. This solution will use a lot of memory, but the read time will be so fast, of 1. So I'm going here to build my hash map or my map database. So I will say, okay, first thing I'm going to do, I will build my map equal to the new hash map. Okay, and I'm just going through the word by word. So I say string word will be word db. I'm going through them. So now, okay, then I will just go through the characters for every word. So for integer I equals 0, I less than word dot is similar for the previous one, I plus plus. But in this case, I'm going to get substrings because I said substring for the word dot substring from the index of 0 to the I, okay, to the end. So you can call this one I, or you can call it an index. So think about this. Think about what you're doing here. So, well, if you give me food, my first key will be F alone, and the value is food. My second key will be FO. My third key will be FOO. My fourth key will be food. So you just every time you get substring of the key, and for the value it will be okay. I already have array list of string. Okay, it's very simple. Will be a list equal map. Try to get our default. Okay, I try to get me whatever this key. So you could call it substring. You could call it just key. And my default value, if I have this key, bring it. If I don't have it, all what you need to do just create a new hash map, a new empty array list. So it will be new array list of string. Okay, that's what I am doing here. And okay, I have it. Now what I do, I just say map dot put the key, and my value will be this list. Okay, and that's it. We build the database. So return the map. So what this guy does, as I told you, if we go through this word, we will have a key F, value of food, key FO, value of food, key FFO, value of food, key FOD, value of food. Then I have a B, value book, BO, book, BOO, book, BOK, book. Then I have another F. Well, I already have a key F before, so I'm not creating a new node. I'm just getting that value which has a food, and I will add full. So now I'll have a key named F, have two values, food and full, and just continue. Then I have the dataset. Now I have the dataset here. Well, the solution now is simple. What I'm doing is just dot db dot get whatever search key you are searching for, and I am all set because I already have all the keys and all the values. So now what I am doing, if I just try to run it, and I will write FO, and the value will be food and full. See now F and all this word. So what we did here is just like, well, let's build everything as a hash map, key values, and try to go through them and read them. If you see it a bit complex, well, what you need to do is your friend is a breakpoint. You just add a breakpoint and then try to go through the solution. So for now, my hash map is empty. I have nothing. I would just go. I have now what my substring is. For now, for my word is, I have not run this line. Food, the word, the key is. I will start from 0 to 0, so this is not good. So because it's 0 to 0 and the key will be 0, so you better start from index of 1 and end to this index, less than or equal. Okay, so I will not get into that point. So that was a simple bug. I was able to find it through debugging. If you just repeat again, so, and I will try to go through them. So I have a word food. So my first key will be F alone. So I have a food. So the key is F. So do I have in hash map, do I have a key F? So my hash map. No, it doesn't have anything yet. So I will just go on create empty list. Well, if you see this is empty, I am going to add that one to that. Well, I am missing something. I guess I'm missing something. Because when I create a list, I need to add my node. Maybe this code is running from the previous solution. So let me just list.put or .add the value I have, which is whatever the word is. Because what I want to do here, I mean, it's better for me to stop and restart. What I want to do here, I'm just going to get the list and add my word to that list. So let me just stop and start again. Okay, I hope now I restarted the code. So I will just try to debug it. Sometimes takes some time. So I would just start debug and I should stop here. Now I will just say, okay, what is my key? My key F. And value is nothing. I will just, okay, my list is empty, doesn't have anything. I will add my word to that list. So see, I have a list and the value is food, and then I add in the hash map. So if you look through the map, you will see you have a key called F and the value is food. And if you just continue, create the second one, you will see the hash map will have a key FO and the value of food. Okay, and just go forward. So I will just stop this, go run, try to see if I just F or U to return full to me, FO to return food, and full F to return food, full, far, fast, these 4 words. Okay, so we should be good. So for now I'm done, and thank you for watching, and see you next.